Hello everyone, welcome to this course on From Zero to Hero in Trigonometry. In the previous lesson, we realized that there is some connection between the angles of a triangle and the ratio of its sides. That is, there is a relationship between the angles and the ratio of the sides. Now, we are going to formally define these relationships using something what we call as trigonometric ratios of the angles of a triangle. So, for the time being, we're going to restrict our discussions to acute angles only, and soon we will see we'll extend our discussions to obtuse angles as well. So, we are going to define trigonometric ratios for angles that measure from 0 degrees to 90 degrees. We'll also see some of the identities that involve these ratios, which we are going to call as trigonometric identities. So to define the trigonometric ratios, let us consider a right angle triangle. Okay, there is an angle A here. So this is A, this is B, and this is C. Yes, I'm going to call this side A, and this is, so A is the side opposite to angle A, and this is side C. Small c is the side opposite to angle C, and this is small b, which is the hypotenuse. It is the angle opposite to angle B. So AB is the side adjacent to angle A, BC is the side opposite to angle A, and AC is the hypotenuse. Now let's try to define the trigonometric ratios. So our first ratio is sine of angle A. Okay, and this will be written as sine A. And this is defined as the side opposite to angle A divided by hypotenuse. So which is BC divided by AC, which is nothing but A over B. Similarly, the next trigonometric ratio is cosine of angle A. And this is written as cos A, and this is nothing but the ratio of side adjacent to angle A divided by hypotenuse. So which is BC by AC ratio, or which is C by B. Okay, and the third, so this is the first trigonometric ratio, this is the second trigonometric ratio, and the third trigonometric ratio is what we call tangent of angle A, and this is written as tan A. And the definition of tangent of A is the side opposite to angle A divided by side opposite to angle side opposite to angle A divided by side adjacent to angle A. So this is nothing but BC divided by AB. Your BC length is A and divided by small c. Right? And you can also observe that this is something which can be represented in terms of sine and cosine of angle A, because this A by C is nothing but sine of angle A divided by cos of angle A. You can see that sine of angle A is nothing but A over B, cos of A is nothing but C over B, and when you divide these two quantities, B will get cancelled and it will give you A over C. Yeah. And the fourth one, the fourth trigonometric ratio is going to be the cosecant of angle A. It is written as cosec A, and the definition is this is 1 over sine of angle A. 1 over sine of angle A is nothing but the hypotenuse divided by side opposite to angle A, which is AC divided by BC, small b divided by small a. So it is nothing but the reciprocal of sine, B by A. And the fifth one is secant of angle A. Secant of angle is defined as written as sec A, and it's defined as 1 over cos A. So this is defined as this will come out as the hypotenuse divided by side adjacent to angle A. So hypotenuse is AC, side adjacent to angle A is AB, and this will be B divided by C. So on the figure you can see that it is B divided by C, and it is nothing but 1 over cos A, because cos A value is nothing but, you can see that cos A value is C by B, cos A value C by B. So if you take reciprocal, you're going to get B by C. And the last one is the sixth trigonometric ratio is cotangent of angle A, and it is defined as 1 over tan A, or it is nothing but, because tan A is nothing but sin A by cos A, so this is also going to be cos A divided by sin A, and it comes out to be the ratio of side adjacent to angle A divided by the side opposite to angle A, which is AB divided by BC. And AB is small c and this is small a. And you can see that this is nothing but the reciprocal of the tangent tan of A. So these are the 6 trigonometric ratios that you need to remember. And these trigonometric ratios of an acute angle that we have taken in a right angle express the relationship between angles and the ratio of the sides. You also need to realize that from our observations, it's clear that the values of trigonometric ratios of an angle do not vary with the length of the sides of the triangle if the angles remain the same. So basically, if you consider a triangle which is similar to our existing triangle, you know that the ratio of the sides is not going to change, and the trigonometric values will also not change. Now let's do a very simple question. Given that A is an acute angle and tan A is equal to 4 by 3, find other trigonometric ratios of angle A. So what we're going to do is we're going to consider a triangle with angle A here, and it's a right angle triangle. This is B and this is C. And since tan A is nothing but, as per our definition, tan A is the opposite side divided by adjacent side. So that is BC divided by AB, that is given to be 4 by 3. So you can take the side length BC as 4 and side length AB as 3, or you can take it as some 4 times some constant, and this is some 3 times some constant. Okay. Now using Pythagoras theorem, you can find the length of AC. AC length will be root over 3k whole square plus 4k whole square. So this is going to be root over 9k square plus 16k square, which is root over 25k square, which is going to be 5k here. Now we can find all the other trigonometric ratios from this triangle. So we have cos A, and cos A is going to be adjacent side divided by hypotenuse. So that will be 3 by 5. Your sin A will be opposite side divided by hypotenuse. That is going to be 4 by 5. Cot A is going to be the reciprocal of tan, which is 3 by 4. Cosec A will be a reciprocal of sin. So this is going to be 5 by 4. Ck is going to be reciprocal of cos, which is going to be 5 by 3.